Right, so finally, it only took me 5 days, but I got the microphone working. Yay, laptop. Okay, so let's have a look at the question. A high resistance voltmeter is corrected across the terminals of the cell and potential difference is measured as 3.5. A 6 ohm resistor is then connected across the cells and this caused the voltmeter to fall to 2.4. So, do you remember that formula I gave you last time on Tuesday for the simultaneous? It was something like V equals E, what was it? E minus IR? E minus IR. Now, at the beginning, there is no resistor connected, and then they add in a 6. So what's happening, now you see that's a little bit strange, because usually what happens is they have 2 different resistors they put into the circuit. That's what we did in class. So they were being a little bit sneaky here. They put in no resistor at the beginning. So it started off with R equals 0 ohms. Now that doesn't mean there's no resistance. There's still the internal small R. What was the voltmeter at the beginning? 3.5. And then when R equals 6 ohms, what's the voltage there? 2.4. Okay. Now, I'll draw the picture here. Oh. You can see. Okay. Yeah, I have a little secret part of the screen here that you can't see. I can draw in here and it's not showing up. Okay. Although you'll see it in the video later. That's interesting. I could write messages here, and you'll only see them if you watch the YouTube video. Okay, I'm drawing something off the screen. You can watch the video later to see what I drew. It's very dirty, by the way. Okay, so we have here you can see that the cell here, and at the very beginning there is no external resistor. You just have the voltmeter connected to it like this. So I hope, well I don't know, it's not very obvious, but that actually means that this 3.5 is the EMF. Because when there's no external resistor connected, what this voltmeter is measuring is like the voltage across this, which has to be the same as this. Now that's kind of hard to see, but another way to kind of think about this is, do you remember on our graph, the y-axis, where it crosses the y-axis, we said that's the EMF. Do you remember that? Now, what do we put on? What do we put at the bottom? It was the current, wasn't it? Yeah. So it's like at the beginning, if you had no external load, then the voltmeter's reading is the EMF. In other words, I don't have a battery. Oh no, I do have a battery. Imagine I took the battery out, okay, no resistor, no light, and I just took a voltmeter and I stuck the voltmeter around the battery. Well then, whatever the voltmeter says the voltage is, that's got to be the battery's voltage, the EMF. Because I mean, what else could it be? There's nothing else could be. So that's why the first question is only 1 mark. Because all you have to do is say the EMF is 3.5. That's it. Now that's a little bit weird. I don't know if anybody figured that out, but we'll go on to the second part now, which is more like what we did yesterday. Oh yeah, so why does the potential fall when the resistor is connected? Well, what's the reason for voltage to drop if the resistance increases? Well, that's kind of like the definition of resistance, isn't it? What does a resistor do? Yeah. So what you could say, how could we explain this for 2 marks now? We could say the total resistance increases, and this means more voltage is, and the word they like to use in the marking scheme, consumed. So basically you up the resistance and then you up the voltage. Since V on, oh for goodness sake, since V on the voltmeter measures V across the resistor. Oh, you've seen the picture I just drew. Sorry, I'll just put that off the screen now. Have you got that? Yes? Ken, you wrote that down? Yeah. Siba, you nearly have it? Okay, can I scroll down? The last part. Let me just stick this over here. So if I use this equation with these two values here, what can I form? So my first equation will be V, which is 3.5. Oh, do we know the current? We don't know. We are not given the current, are we? So what do we need to change in our formula? The I. Yeah, let's see. So what could I replace I with? VI or V over or. Okay. Times small r. Right, do I know the V? I do. I don't know the E. I know the V. Oh, hang on. No. I know the E, don't I? Yeah. Do I know the small r? No. If I look at this one here, do I know the big V? I do. And do I know the big R? I do. Yeah, no, see, I just realized I can't use the first equation because there is no external resistor. I can't divide by 0, so I have to use the second one. But it's okay because I know what the E is. So it reduces one of my unknowns down to one unknown. So here I get, let's see, 2.4 equals 3.5 minus 2.4 over 6 times small r. So that's 2.4 over 6 r equals 1.1, I think, I hope, I dream. So that means r is 6.6 over 2.4. What's that, please? 6.6 over 2.4? 2.75 ohms, huh? Do you have Moodle handy there, Siva? Do you want to have a look at, check the answer?
Their answer?
Yeah. You think I'm a cruel teacher who wouldn't give you answers with questions? Yes, you do think I'm cruel, don't you? Yes?
The external resistance is added outside the voltmeter or inside the voltmeter?
It's weird, but it doesn't matter. And I can explain in a moment why it doesn't matter. I know it seems like it should matter, but it doesn't matter.
Where is it?
It should be like the link under the... Can I scroll down? So let me show you why. Imagine here's the battery, okay? And then here's the external resistor here, like that. This side's positive and that side's negative, isn't it? If I put the voltmeter here, I'm measuring the voltage around what? resistor. What if I put the voltmeter here instead? Here. Just, can you see where this is going? What about here? You know, and then eventually I end up here. This is quite weird, but having the voltmeter around the battery or having the voltmeter around the resistor, same effect. For me personally, even if the voltmeter is around the battery, I always like to imagine it around the resistor, because it's kind of easier in my head that way. So I don't like the voltmeter around the battery. It kind of confuses me because it looks nicer to have it down by the resistor. Because then, if the voltmeter is around the resistor, then it makes this very clear. So the I is definitely the I coming out of the resistor. You know, that's how I like to think about it. You have the answer there, Stephen? So what did they say? I'm curious what they said for part 2. Their words.
Some of the cell's EMF is used in driving the current through the cell's own internal resistance, which is in series with a 6 ohm resistor, so the terminal CD cell.
Wow, what a lot for 2 marks. I just wrote more resistance means more voltage. I wonder if I would have given myself 2 marks. I think I would have. It's a bit unfortunate because the person who writes the exam is different. So in some years they would have just taken a short answer like more resistance means more voltage is consumed. But the new person who writes the exams likes his English, so he likes things to be longer. You might just want to remember that, okay? I can close this, we can do another one now. Are we finished all the electricity questions? Yeah? How do I stop recording? Save recording, I guess?